All right, let's look at the homework 9, problem number 7. All right, so we want to show this rational function is onto. All right, so let's do that. So let's write down the definition. So in order to show that the function is onto, we have to show that for all, say, b in the codomain, which is the all real numbers except for 5, right, there exists at least one corresponding a in the domain, which is the all real numbers except for 2, right, such that f of a is exactly equal to b. Right, so that's what we need to show. Right, so what we're going to do is I'm going to do a little bit of scratch work so that we can have a formula for a. Right, so here is my scratch work. Alright, so we want f of a, so f of a, which is just to plug in x equals a, so it's going to be 5a plus 1 over a minus 2. And we want this guy to be exactly equal to b. So let's solve this equation for a. Alright, so first, multiply both sides by quantity a minus 2. You will get 5a plus 1 is equal to b times a minus b times 2. Right? Then I'm going to put, let's see, everything on the, let's see, all of the ones with a on the right and everything else on the left. So I'm going to add 2b to both sides and also subtract the 5a. Right? So you're going to have a 2b here, and 5a is gone, so it's a plus 1 is equal to, so 2b is gone, and you have a b a minus 5a. So I'm going to write it as b minus 5a. Alright, then we can solve for a, isolate a by dividing through by quantity b minus 5. So you have a 2b plus 1 over b minus 5. So that's going to be a. Right? So we found the formula for a. Right? And I want to make sure that this is actually in all real numbers except for 2. So do we know that this is not equal to 2? Right? So one thing we can do is I can rewrite this guy as 2b. Right, or actually, maybe let's do a long division. It might be a good place to do it. So if I do a long division, 2b plus 1 divided by, say, b minus 5, right? Then you can have two of them. So you have a 2b minus 10. So 1 minus negative 10, so that's going to be 11. So this can be written as 2 plus remainder is 11 over divisor is b minus 5. Right? So you can see that it's going to be 2 plus something, and this something, this guy is actually never 0. Right? Which means that this quantity is never equal to 2. Right? So that's great. Alright, so let's go back to the proof. Alright, so we want to show that. Alright, so we're going to start with, let's choose any b, which is the real number, except for 5. Right? Then we know that there exists a, which is in the form of 2b plus 1 over b minus 5. Right, that came from here, right here, right? And we just verify that this is actually a real number, and that is never equal to 2. Right? and such that, right, then you can see that if you do f of a, which is equal to, right, it's same thing as f of 2b plus 1 minus b minus 5. And if you do that, so we have to replace x by 2b plus 1 over b minus 5. So it's a 5 times 2b plus 1 over b minus 5 plus 1 over, right, you have a 2b plus 1 over b minus 5 minus 2. Right? So the easiest way to simplify would be, I'm going to multiply numerator and denominator by b minus 5 so that I can get rid of the fraction inside a fraction. So b minus 5. Right? You have to do the same to top and bottom. Right? So this will give us, right, so b minus 5 here cancel out, so you're gonna I'm gonna just distribute 5, so you're gonna 5 times 2b is 10b, 5 times 1 is 5, right, then b minus 5 is gone, and 1 times b minus 5 is of course b minus 5, and divided through by, right, so same thing, so you have a 2b plus 1 is there, minus, right, 2 times, so it's going to be negative 2 times b is negative 2b, negative 2 times negative 5 is plus 10, right? Then let's simplify. So we can cancel, there's 5 there, and there's negative 5 there, and there's a 2b there, and a negative 2b there. So you can see that this is going to be equal to, on top, 11b over 1 plus 10, 11. So we can still cancel 11 to get b. Right? So this shows that pick any arbitrary v value from the codomain, we could successfully find a because we actually figure out the formula to find a, so that the f of a is exactly equal to f of b. So therefore, we show that the f is on 2. Right? That's it. I hope that this was clear.